So the second type of improper integrals, those with discontinuities, we looked at the one where we had, what was it, 0 to 1, 0 to 2, 1 over, I don't think it's the same one, 1 over x minus 1. Yeah, you got a problem there because 1, you can't do x as 1. It's not undefined that x is 1, and so that's discontinuity at x equals 1. And so that's why it's grouped into these, what are known as improper integrals. So what do we do? Well, let's not start with that one. Let's start with this one. Because, well, let's work our way to that one, or one like that one. Okay, so this one is a little different because that one has the discontinuity in the middle. Here, where's the discontinuity on this one? One of the limits, right? The discontinuity is at one of the limits. And so, like I said, we'll deal with one where the discontinuity is in the middle or somewhere in between them. But here, the discontinuity occurs at one of the limits, 0. So it's discontinuous at 0. And so that's our improperness occurs. So, just like we did with the infinities, we're going to replace the discontinuity by the t. So I'm going to do the limit as t. Now, on the discontinuities, one thing you have to pay attention to, because sometimes it makes a difference, which side of the discontinuity are we talking about? So yeah, we're wanting t go to 0, but in this particular case, it's we're going between, if I think about the graph here, I'm going from 0 to 1, and so I want the stuff in here, so I want to approach 0 from the right. Like I said, that's important sometimes, because sometimes it makes a difference between infinity or negative infinity or converging or diverging. Anyway, so it's 0 from the right. Then we got t to 1, we replace the 0. And let's go ahead and write, that's x to the minus a half. Let's go ahead and rewrite that so we can get to the antiderivative here. But you're with me there? Okay, so that's the limit as t goes to 0 from the right. Just power rule, so add 1, be a positive a half. So we're going to divide up here by the reciprocal, 2 over 1. And so that's t to 1. I believe is our antiderivative. Is that right? Believe that? So that's the limit as t goes to 0 from the right. Plug in the 1, we got 2 times 1 to 1/2, so that's just 1, minus 2 t to the 1/2. Okay. And so some of them, like I said, are easier than others. This one's pretty easy now, isn't it? Because I can't plug in t to be 0. That's just 0. Which makes that 0. So it's just 2. Yep. All right. How about this one? Integral 0 to 1, 1 over x minus 1 to the 2/3 dx. All right, so what do I need to replace here by the t? What's the discontinuity here? Discontinuity here is not 0, is it? Discontinuity here is 1. Because x can't be 1 when I substitute it in. And so that's what t needs to go to, is the 1. Now, is that from the right or left? Like I said, on these discontinuities, you need to determine, because sometimes it makes a difference. May not here, but at some point it will. Right or left. So again, I'm going from 0 to 1. So 1, I need to approach it from the left, don't I? And so it doesn't a lot of times make a difference, but look at it up front, make sure, but just in case. So that'd be 0 to t, and let's go ahead and change that. That'd be x minus 1 to the negative 2/3 dx. How are we going to do that? Well, be sure, but it is a u substitution, but du is dx, so it's a simple, real simple one. There's no factor that we have to replace dx by, so it's a simple one. These are x values. U to the negative 2/3. Yeah. So that's just simple power rule. Be add 1, so it would be 1/3 power, 3 to the 1, 3 over 1 here. Let's go ahead and change that to x minus 1. What is it? 1/3. Do that from 0 to t, so you got limit as t goes to 1. From the left, 3, t minus 1 to the 1/3. Minus 3 times negative 1 to the 1/3. Plug in the 0, you get negative 1 to the 1/3, right? All right. So substitute in t is 1. Yeah, this is going to be 0, 3 times 0, isn't it? Minus 3, it's negative 1 also. Negative 1 to 1/3 is negative 1. Positive 3. So that one converges, another one that converges. Question? All right. One more of these, and then we'll do one where we have the discontinuity in the middle. All right, so 1 over x, and we're going from negative 1 to 0. So again, 0 is the discontinuity. Right? So that'll be what t replaces. It's limit as t goes to 0, and I think this is one where it does make a difference. So is that from the left or right of 0? From the left to 0, yeah, because I'm going negative 1 to 0. And so I'm trying to do it here, so I would approach 0 from the left. And like I said, this one does make a difference. Whether we approach right from the left, from the right or from the left. Okay. What do you got there? Ln. So its limit as t goes to 0 from the left. Ln of absolute value of x, evaluate that from negative 1 to t. So we plug in the values. The Ln of the absolute value of t minus Ln absolute value of negative 1. That's what we're doing there. Of course, this is Ln of 1. What's Ln of 1? 0, yeah. That's 0. So we're just dealing with this. What does this do as t approaches 0 from the left? Should we look at the graph? Yeah, let's look at the graph. Yeah, so if you have a question, look at the graph. In this case, we're graphing y equals and b absolute value of x, ln of absolute value of x. Because if you just do the ln of x, you won't approach 0 from the left, because you can't have 0 from the left if you just do ln of x. It's got to be the ln of absolute value of x. But it mirrors ln of x. Is that what you get it looking like? ln of absolute value of x? Anybody get it? Sort of what it looks like? So, what is this then? What is that? T approaches 0 from the left. Here's 0, approaching from the left. I don't guess it really mattered left or right, would it? But we're approaching from the left, so negative infinity, isn't it? This one's a divergent one. Another divergent one. Yeah, let's go ahead. Let's go ahead and do that too. I said I was going to do the one where I did discontinuity in the middle, but let me show you this one because this has another thing that pops up. So negative 1 to 0, 1 over x squared dx. Similar, very, very similar to the previous one. So again, approach 0 from the left. T approaches 0 from the left. Negative 1 to t then. This is just going to be power rule though. So it's a little different. That's x to the negative 2, so the interval is going to be negative x to the negative 1. T. So we have the limit as t goes to 0 from the left. Negative t to the negative 1 minus negative 1 to the negative 1. Let's go ahead and flip that over here. That's negative 1 over t. That's plus 1. So we've got t going to 0. What happens when the denominator goes to 0? Undefined? How so? You say how it's undefined? It is undefined, but again, if you look at the graph, could help you.
Positive infinity.
Positive infinity? Is that what you're seeing? Yeah, if you look at the graph here of negative 1 over t, yeah, that's that. 1 over x. So as we approach 0 from the left, it's going to positive infinity. Plus 1, that's not going to change the fact that it's going to infinity. Yep. Both of those are divergent. Question or concern? Okay. One last one. And that is one where we've got the discontinuity in the middle. 0 to 3, 1 over x minus 2 to the 3/5 x. Yeah, so this one, 0's okay, 3's okay, but what's not okay? 2's not okay. Yeah, our discontinuity's at 2. And so we've got to break it up there. So we've got to do 0 to 2, 1 over x minus 2 to the 3/5. And then plus 2 to 3, 1 over x minus 2 to the 3/5. That's how we can do this one. So here, that's going to be the limit as t approaches 2. So I've got to replace the 2 by t. That's going to be approaching 2 from the right, right? To go 0 to 2, 2 approaches 2 from the right. Let's write that as x minus 2 to the 3/5 because it's just going to be power rule. And then here, the limit as t approaches 2, but it's from the left because you're going from 2 to 3. Or did I do that backwards?
Yeah, I did it backwards.
This is, yeah, should have drawn it. So I'm going 0 to 2, so yeah, I'm approaching 2 from the left here. And then this is approaching 2 from the right. Thank you. So that'd be t to 3, x minus 2 to the minus 3/5. So we'll just do power rule there. And again, it's a u substitution, but since du is just dx, there's no factor there we have to contend with, so it's just going to be power rule. So limit as t goes to 2 from the left. New power, add 1, 8/5. It'll be 5/8. 0 to t. And then this one, limit as t goes to 2 from the right. Oh, it's minus 3/5. Sorry. It's not 8/5. 2/5. So it'll be 5/2. Sorry about that. It's getting late. Is that right? 5/2. Does anybody believe that now? Yeah, so it was negative 3/5, so you add 1 is 2/5. So yeah, all right. I'm good with that now. So the same thing over here. 5/2. X minus 2 to the 2/5. And then we're going t to 3. What goes in? 5/2 t minus 2 to the 2/5 minus 5/2 negative 2 to the 2/5. And over here we've got the limit as t goes to 2 from the right. So 5/2. Oh, that's good. 1 to the 2/5. And then t minus 5/2. Get rid of this one. T minus 2 to the 2/5. Okay. Oh. So this is good. We don't have to do the graph thing because t equals 2. That's just 0, isn't it? So we'll just have minus 5/2, negative 2 to the 2/5. So do like that for a second. Plus, same thing over here happens. T goes to 2, so that's 5. Oh, that's easy though. 1 to the 2/5. 1 to anything is 1. And this is 0 again. T goes to 2, so that's just 0. So that's 0. That's 0. So we just have these two. Which, if you write them that way, that's okay, but let me just show you here. That's the same, so we'll do a little work on that. That's the same as the 5th root of negative 2 squared, isn't it? And negative 2 squared is 4. So that's the same as the 5th root of 4. Plus 5/2. And you factor off the 5/2, however you write it, but that's probably close to what they would write in the back. They would probably do something. They may switch them around, make it 5/2 times 1. Is that okay?